So today we are going to start with the next topic, that is solar energy and solar power plant. This is the We have started the renewable energy sources, that is non-conventional energy sources. That is first source is solar energy, and from this solar energy we can generate the electricity. So it is also called as a solar power plant, where we can generate the electricity or electrical energy. So this is the next topic in unit number 1, that is introduction to energy sources. So we'll see what is meant by solar energy. So from a of uh, consumption pattern of these fossil fuels or various fossil fuels like natural gas, fuel oil, it may be petrol, diesel, coal, etc. It has been estimated that these petroleum products and coal are not going to last beyond next 50 to 100 years. So there is a depletion of these various types of fossil fuels in next 20, 50 to 100 years. And as a result of this depletion, every country needs to develop a new technology which makes use of a non-conventional or a renewable source of energy, such as solar energy, wind energy, tidal energy, geothermal energy. These are the some sources of non-conventional energies. So the every country which needs to develop these technologies where we can use these non-conventional energy sources to uh, complete the energy needs requirement. So in spite of there is numerous distance between sun and earth, the radiation output by the sun, it is very powerful, and the earth is shielded from various harmful effects of radiation by atmosphere which surrounded the earth, that particularly ozone layer. So because of ozone layer, the radiation or harmful effect of radiation, it does not goes to earth, and this is because of ozone layer. So that layer, it is present in stratosphere. So it is estimated that the earth receives almost 10 raised to 18 kilowatt hour of solar energy every year, and this total annual energy requirement of our world, it is 80 into 10 raised to 12. So this energy received from solar, that can be also used 100%ly, so that will annual energy requirement of world is also get satisfied. So this shows that the world energy consumption can be met if small percentage of sunlight incident on uh, earth is effectively utilized. We can reduce the dependability on various fossil fuels and all that. So this is the basic concept regarding the solar energy. Now this solar energy, it can be utilized for different ways. So it is, we can use for solar energy for electricity generation or power generation. Then it is for storage. It is for heating. So for different purpose, we can use this solar energy. So the first application of this solar energy is the solar heater. So by using solar radiation, we can heat a water or any type of fluid by using either flat plate collector or by using parabolic reflector. So by using these two types of collectors, one is flat plate and another one is parabolic reflectors. So we can heat the water or any types of fluid by using solar radiation. So solar water heating system is has many applications in domestic as well as in industrial sectors. Such systems can provide hot waters for different application in industry directly. So this is the direct application. So from this hot water, we can provide this hot water for different application of industry as well as for uh, the domestic buildings, then hotels, canteens, where hot water is required. And indirectly, we have a boiler field. This hot water can be filled to the boiler so as to convert the hot water into a steam. So these are the applications of these solar heaters. So one of the example of solar heaters is shown here. So this is one type of collector, that is flat plate collector are there. And from this flat plate collector, the water is flowing through these tubes, various tubes. And because of solar radiation, the heat transfer takes place between sun and the water, and water gets heated. So this is the first application of this uh, solar energy, that is solar heater. Now we use these two types of collector. One is flat plate collector and another one is parabolic reflector. So we'll see this, what is meant by flat plate collector and parabolic reflectors. So first we will see the flat plate collector. Now if you see the flat plate collector, the arrangement of flat plate collector is shown in this figure. So if you see, there are number of tubes are there. From that tubes, the water, or we can say hot water, is flowing. So at from one end, the cold water gets in. After heating, the hot water gets out from another end. So the arrangement of this solar heater using solar flat plate collector is shown in this figure. So the absorber plate, normally this plate, it is a metallic plate where it absorbs the sun rays, and it is usually coated black to absorb more thermal energy or a radiation, because black surface or black body, it has highest absorbing rate, that is almost 100%. The black body absorbs the energy. So for that we use a black coated plate, which is normally made up of metals. Now tubes or passage or channel, it is an integral with this collector, which carries either water or air or any other working fluids. So we can heat the water, air or any other working fluids, and these tubes or passage or channels by which we can flow this working fluid. Again, the insulation is also provided at the back side and at the sides to minimize heat losses. So insulation is very much important to minimize the heat losses, and usually a glass pool, it is used as an insulating material. Now another, a transparent cover is there. This transparent cover is usually made up of glass. It's showed provided at the top of this uh, flat plate collector, will permit the radiation from sun to the metal plate. And since it is a shorter wavelength, when radiation strikes on the plate, the part of energy gets reflected back to the cover. So some amount of energy is absorbed, some amount of energy gets reflected to cover, and because of it transparent cover, this again reflected energy, it again passes to that black metallic flat plate collector. So again energy gets absorbed. So as a radiation has higher wavelength, uh, it will not go out of atmosphere. So instead of, the cover will reflect the energy back to the absorber plate, where again that absorbs the sun radiation or radiation from sun, and that will increase the heat transfer rate. That will increase the heat transfer rate. So if there is no transparent cover is there, the reflected energy that been lost. So transparent cover is required to increase the heat transfer rate. So because of this transparent cover, the radiation or rays from sun is again transferred to absorber plate where it gets again absorbed and that convert it into a heat. Again, if a circulating fluid is a water, the hot water can be collected in a tank or it can be recirculated. So here is a tank where we can collect the hot water from this heating of this heating is done by using these solar radiations. So here is a tank where we can store the hot water and whenever required we can use that hot water. A small water circulating pump is there inside this flat plate collector. So because of this, it will pressurize the fluid inside the tubes, and because of using this such system, it gives better result and it also improves the heat transfer. So this is the first type of collector. That collector is known as a flat plate collector. Now we have another type of collector, that is second collector. It is the parabolic type of collector. Now this parabolic collector is shown in this figure. So we have a curve like a parabola. That collector is there. So that is called as a parabolic collector, or it is also called as a parabolic reflector. So this parabolic reflector, it is highly polished metallic surface that is used as a parabolic reflector. So this reflector, which normally has a parabolic shape, so that sun rays striking on this profile will gets again reflected to some focal point. So in that focal point, we have a absorber tube. So sun rays is incident on this parabolic curve or parabolic shape. Then it will be reflected to this absorber tube where the this reflected rays is absorbed by using absorber tube. So a tube, absorber tube, it carries a fluid which is kept along this focal line so that fluid gets heated with very high temperature. So by using this parabolic reflector, the water temperature it becomes higher. So this is second type of parabolic reflector. So these two solar heaters, either by using flat plate collector or by using parabolic reflector, they are used for the heating purpose. So heating of water will be there, heating of air will be there, heating of other working fluids are there. So that will be there. So this is the first use of this solar energy, that is solar heaters. Now another, this solar energy, it can be used for power generation also. So power generation, it is known as solar power generation. So the World Energy Councils, it predicted that almost 75% of growth in demand for energy by 2020. So it is almost predicted. And the most of electricity is generated from coal is leading with the emission of greenhouse effects or greenhouse gases like CO2. And because of that COP, there is a most common problem, that is a global warming. So which the world is trying to reduce this greenhouse effect. After there is a summit which is held in Kyoto on climate change in 1997, and the ministerial meeting in Buenos Aires in 1998. So we are trying, or all countries are trying to reduce their dependability on these fossil fuels because of emission of greenhouse gases, and that will lead to the global warming. So today, the use of this solar energy for power generation getting more attention in this solar energy by using power generation. So because it is a eco-friendly, there is no any harmful effect on this solar energy converting the power. Now at present, the cost of converting solar power into electricity, it may be high, but in future it is expected to come down. Cost of this solar power plant will be less. This is another part. Now another will be there, how the power generation will be takes place. So recently a British company has developed a system which uses a fixed concave mirrors to trap and concentrate the solar energy. So one of the British company has developed this system, that is fixed concave mirrors, where it used to trap and concentrate the solar energy, and which heat air about 1000 degrees Celsius. So this hot air uh, turns devices like gas turbine, which generates the electricity. So one of such system, it is built on a Mediterranean island of great employ, in which the 800 meters square mirrors fixed at ground levels, producing almost about 35 kilowatt of power. So by using this uh, devices, that is fixed concave mirrors, about 800 meter square area, it produces almost 35 kilowatt of power. And this power, it can be used in remote areas, hospitals, hostels, and also this can be, it is used in distillation of water, then air conditioning plant, and sometimes that can be used for cooking also. So this is the recent development. Now the solar energy, the direct conversion of solar energy into electricity is also possible using a photovoltaic effect of certain materials. So it is all called as famous word PV effect. So where there is a direct conversion of solar energy into electricity or electrical energy, that is PV cells, or it is also called as solar cells. So the basic unit of this photovoltaic cell is a solar cell, and the first practical of this solar cell was introduced in 1954 by the Bell Telephone Laboratories in United States of America. So this cell was made up of a single crystal silicon, and a solar cell is a semiconductor device processed and fabricated in a manner which permits a generation of voltage. So solar cell produces a voltage when the lights is fall on this silicon material. So the voltage is capable for driving electric current through electric circuit. Now, this power from solar cell, it can be used for various operations of calculator, pump set, radio station, then we have TV station, satellite, etc. So the power obtained in the daytime can be stored in batteries, and at present, the cost of this power unit is very high, and that can be again reduced in future. So this is the how we can generate the solar. We can convert the solar energy into a power, that is the electrical energy or electricity. So we'll see the different types of power generation by using different types of methods. By using, we can convert this power into this solar energy into an electricity or electrical energy. So the first power generation of this solar power plant is by using a butane boiler. So this is the solar power plant by using butane boiler. So a water in flat plate collector, we can heat the water in flat plate collector up to 70 to 80 degrees Celsius by using this solar radiation. So we have a flat plate collector here. So solar radiation will fall on this flat plate collector, and there is a circulating pump which feed the water inside this flat plate collector, and the water inside this, it can be heated up to 70 degrees Celsius to 80 degrees Celsius. So a butane, it is one of the element. It vaporizes at 50 degrees Celsius. So water becomes vapors at 50 degrees Celsius. So water at 70 to 80 degrees Celsius is able to vaporize by using butane. So there is a butane boiler is used where we can vaporize this water which is of 70 to 80 degrees Celsius. And the hot water after transferring heat to butane is pumped by a circulating pump to the flat plate collector where it is again heated, and this cycle goes on completely. Now the butane vapor, that is, it is the vapors almost at 50 degrees Celsius from boiler is taken into a butane turbine. So in this we require a butane turbine which connected to electrical generator. So the steam or vaporized water or steam is passed to the butane boiler where the rotation of turbine will be there, and will have the electricity. So the butane boiler, butane turbine converts this uh, butane steam or butane vapors into an mechanical work, and we get again a low temperature butane steam that will again condenser is there where we can convert that butane steam into a droplet water, and again by using feed pump we pass this to butane boiler. So this cycle will get completed every time, and again turbine is connected to generator where generator converts the mechanical energy of turbine butane turbine to electrical energy. So exhaust vapor from turbine is again condensed in condenser, and the liquid butane is pumped by a feed pump again to the butane boiler, and this cycle goes on repeating. So if you see the cycle between thermal power plant and this butane solar power using butane boiler, only difference is that boiler is there in both, but here boiler is for only transferring heat, and the by using solar radiation we can heat the water, and that water heating is get transfer into butane boiler where it gets vaporized. Now there is we require a steam turbine, here we require a butane turbine. All other parts, that is generator, condenser, circulate cooling water, that is nothing but the cooling towers, feed pump, these all other parts and process will be same. Only difference is that we heat the water up to 70 to 80 degrees Celsius, and we passes to the butane boiler where it gets vaporized, and we convert that vaporized steam into an mechanical power by using butane turbine. So this is the first method to convert solar energy into electricity. Now there is another method where we can convert. Now we'll see the what are the advantages and disadvantages of this solar power plant using butane boiler. So first advantage is the heat energy from sun. It is freely available. So there is no pollution problem, and also uh, the energy is also freely available. Second, there is no transportation and storage problem of the fuel is there, because the sun radiation it is used, so there is no other fuel is required for this solar power plant. This solar power plant, it is easy to construct and easy to erect or operation. Now there is disadvantages. We know that the solar energy is available during the daytime. So during night time, this solar power plant, it may be stopped, and the power produced by this solar power plant is very small compared to other types of power plants. So these are the some advantages and disadvantages of this solar power plant by using butane boiler. Now we have a main part of this solar energy where we can convert solar energy to direct electrical energy. In solar power plant, we have convert solar energy to heat energy, then heat energy to vaporize a butane, then from vaporized butane to mechanical energy, and then mechanical energy to electrical energy. Here, in solar PV cell, we convert the solar energy into direct electrical energy. So because of that, it is called as a solar cell. So there is only one conversion of energy is there from solar to electrical. So this a solar cell, which is also known as photovoltaic cell, or it is also known as PV cell, is defined as an electrical device. So solar cell or PV cell, it is an electrical device that converts the light energy, that is the solar energy, light energy of sun into electrical energy through photovoltaic effect. So by this effect, we can convert light energy into an electrical energy. A solar energy is a basically PN junction diode. So a cell or PV cell, it is a PN junction diode. Solar cells are a form of photovoltaic cell or photoelectric cell, which is defined as it is a device whose electrical characteristics vary when we exposed this cell to the light. So what are the electric characteristics? It may be voltage, it may be current, or it may be resistance. So when light energy is incident on this photovoltaic cell, or we can say photoelectric cell, this electrical characteristics of a device, it get varies, that is voltage, current, and resistance. So individual solar cells can be combined to form a modulus, which is commonly known as solar panels. And the common single junctions of silicon solar cell can produce a maximum open circuit voltage of approximately 5 0.56 to 0.6 volt. So one single cell produces the voltage of 0.56 to 0.5 to zero point 0.6 volt, and the combination of these solar cells form a solar panel. So by itself, uh, it much, but remember these solar cells as a tiny part, because it gives a small 0.5 to zero point 0.6 volt of voltage, but this solar cell is a very small part. So when we combine into a large solar panel, the considerable amount of renewable energy it can be generated by using this solar cell. Single solar cell is it is a small part, so we use the combination of these solar cells, and this combination of solar cells is combined to a large solar panel, and from that solar panel we get considerably large amount of renewable energy. Now we'll see the construction and working principle of this solar energy or solar cell. So if you see, there are electron is there, then we have holes, or it is also called as a proton. Then we have photon. There p-type and n-type junction will be there. Depletion zone will be there. This electron hole will be there. When this electron gets passing through this electric circuit, the electrical current gets flow and we get the electricity by using this solar cell. So we'll see the working behind this solar cell and what are the construction of this solar cell. So mainly if you see a solar cell, it is a basic a PN junction diode. So the construction is little bit same, a little bit different from your PN junction diode. There is a very thin layer of this P type of semiconductor. A very thin layer of P type of semiconductor is there. Is grown relatively thicker N type of semiconductor. Now we have this N type of semiconductor. So these electrodes do not obstruct light to reach the thin p-type layer. So just below p-type layer, there is a p-n junction. So we also provide a current collecting the electrode. At the bottom of the n-type layer, we have a electrode. And we encapsulate this entire assembly by using a thin glass to protect solar cell from any other mechanical shock or any other mechanical vibration. So when light reaches to this PN junction, the light photons can easily enter into a junction through very thin type of p-type layer, and the light energy in the form of photon is sufficiently supply energy to the junction to create number of electrons and number of holes. So this light energy gets split up into electrons and photons, or we can say it is a this part it is called as a photon, this green color part it is called as a electron, and this red color part it is called as a hole. So the light energy in the form of photon we supply on this PN junction diode, or we can say PV cell, which creates the electron and hole pair. Because of this photon, that is light energy, that will convert into an electron and holes. So the incident light breaks the thermal equilibrium condition of junction, and the free electron in depletion region. So in this region, the free electron can quickly come to N type of junction. So they are quickly coming to this N type of junction, and this is the P type of junction. Similarly, the holes in depletion, it can be come to the P type of junction. Once newly created free electrons come to the N side, it cannot cross the junction because of potential barrier. Similarly, newly created holes once comes to p-type junction, it cannot cross that junction and becomes higher in one side. So the n-type side junction and concentration of hole become more in another side. The p-type junction and pn-type junction will behave a small like a battery cell. This p-type junction and n-type junction is behaves like a small cell or battery cell, and the voltage is set up between these two uh, P junction and N junction. That voltage is known as photo voltage. Photo voltage. So if we connect this small load across this junction, there will be a small or tiny amount of current flowing through this junction. So this is a construction and working behind this solar cell. Now we'll see the how this solar cell works. Now the first is the solar cell. It is a junction diode, PN junction diode, where construction is little bit different from your PN junction diode. When light reaches to PN junction, light photons get easily enter into junction into P type, and the light energy forms the photon sufficiently supplies the energy to the junction to create the pair of this electron and photon, uh, electron and holes. So the holes in depletion can quickly come to the p-type junction, and once newly created free electrons come to n-type of newly junction, it cannot cross the barrier because of potential of junction. Similarly, newly created holes is comes to the p-type of junction, and inert it also cannot cross the junction and becomes a barrier. So electron comes to this n type of junction and holes come to this p type of junction, and in it cannot cross this layer, depletion layer, that is p type junction and n type junction. So as the concentration of this electron becomes higher in one side, that is in n type of side of the junction, and concentration hall of holes becomes more in another sides. So concentration of this electron, it is higher in one end, and concentration of holes is higher in second end, that is in n type, and this is in p type. So because of this, PN junction will behave like a small battery cell, and the voltage is set up, and that voltage is known as photo voltage. So we can connect the small load across this photo voltage, and from that the small amount of tiny amount of current will flow. So this is the construction and working principle of solar cell. Now we will see the advantages, disadvantages, and how can use this solar cell for power generation. So first advantages of this solar cell: no pollution is associated with them. Second, it this solar cell, it can be used for long time, and there is no maintenance cost required for this solar cell. Uh, the what are the disadvantages? It has very high cost for installation. It has very low efficiency. Uh, During the cloudy day or during the night, the energy cannot be produced. So these are the disadvantages. And what are the uses of this solar cell for power generation or solar generation? It may be used to charge the battery. These solar cells or PV cells are used to charge battery. It can be used in light meters. Then it is used for power calculator, wristwatches, where a small amount of power is required, and it can be used in spacecraft to provide some electrical energy. So these are the some uh, usage of this solar generation system using either solar cell or using either uh, power or butane boiler. So this is all about we can say uh, solar energy and how we can use that solar energy to heat energy, to electrical energy, or solar cell light energy to electrical energy by using PV cell. So we have seen the different applications of this solar energy, advantages, disadvantages, usage. Okay, so this is about a solar energy and the solar power plant. So this is I am ending this video, and please do subscribe my channel. Thank you very much for listening this video.